And 6.6, we're now combining transformations of the sinusoidal functions. Sinusoidal functions, well, obviously that's referring to sine, but it's also referring to cosine. Both of those are sinusoidal functions. And I know a bunch of you are still thinking cosine is what your parents did when you went and bought your vehicle, but we're talking trigonometry here. Just do a quick reminder on your transformations. Okay, so we've got y equals fx going to this whole jazz there. So let's start with our stretches. It's always stretch and reflect. You can do those in either order. Sometimes we'll reflect before stretching, sometimes stretch before reflecting. But those have to be done before your translations. That has to be done last. Let's look at all of our replacements then. Let's start with our x and the stretches. Okay, so in this case, x is replaced with, you can see it in here, 2x. You got to make sure, as always, I keep saying it, this has to be double bracketed for us to talk about our transformations. So first thing is our b value. So we've got a, b, and h and k is what we went over before. The h and the k, as soon as we get to trigonometry, we're going to change that to a c and a d. So every single time we get x replaced with 2x, we've got a horizontal, because it's x, stretch because we're multiplying, by a factor of the reciprocal, 1/2. That's our b value that did that one first. Our a value, that was y. It actually came from the other side of the equation. It's really this y. This came from the other side of the equation with the y. But that's a vertical stretch by a factor of. And it's on the wrong side of the equation, so it's already had the reciprocal taken. We just slow it down at 1/2. Then we've got our h, which is now going to be our c. That's our horizontal translation. And that's going 4 units to the right. Got to take the opposite sign when it's where it's supposed to be. And our vertical translation. That's the d value, that k. It's where it's supposed to be. It's with the y, so we need to do the opposite. It's a vertical translation of 3 units down. All right, let's go through each one of those now. Horizontal stretch by a factor of 1/2. That means x is multiplied by 1/2. Vertical stretch, that the y is multiplied by 1/2. Horizontal translation, add 4 to x and 3 down, subtract 3 from y. Let's do each one of those things to every point. Find a point and go with it. So this point here, go multiply by 1/2 on the x and on the y. So what we're doing with each xy point, the original is x and y. First thing you're going to do with our mapping notation, we're going to divide each of them by 2 or multiply each by 1/2. So we'll have x over 2, and we'll have y divided by 2. And then we're adding 4 to the x, so plus 4, and we're subtracting 3 from the y, so subtract 3. Plug that into each point. Take a point, plug it in here, find it. Take a point, plug it in, find it. So I'm just going to actually start with this point, -6, comma, what is that? That's 2. -6 divided by 2, -3, plus 4. That one's going to 1, comma. And the 2 divided by 2 is 1, minus 3, -2. I'm going to plot it. So that's this point I just did here. Plot it at 1, comma, -2. Oops, sorry. Let's actually use 1, not -1 there. There we go. That's the place. And this is moving 1, 2. We're going over to the right. Because this is our next point here I'll use is -4 and 6. Plug that one in there. -4 and 6. Throw in to the same thing. You're going to get 2 and 0. Do the same thing with the next point. Let's use that point there, 4, 6. And that one's going to be 6, 0 when you work it through the mapping. And then you've got the point 8, -2. And that's going to go to 8 and -4. And we throw each one of those down. And that's where I end up with the rest of the graph. And we've got now a sine of x graph there. Let's graph sine of 2x. Right there, that is saying that we've got a horizontal stretch by a factor of 1/2. That means that we're multiplying all the x's by a half. So we've got this right there. We'll multiply it by half, and it'll end up being over here. Next point, does that go half of the distance? That'll be here. Then the next one, this, half the distance. That's 1, 2, 3, 4, 5. That's 6 tick marks, so we are going to 3 tick marks. 1, 2, 3, third tick mark. Count the tick marks, and then just go half the distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to go to 5 tick marks on the next one. 1, 2, 3, 4, 5 right there. We've got all the way here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks. We're going 6. 4, 5, 6. And let's connect those dots. That pattern is going to continue. So down, back up, down, back down, up to there. So let's finish off the next cycle in there. We could go backwards as well. So that's going to be half into here, and then up to there, and back down to there, like that. And make sure you label that graph, y equals sine of 2x. Next one, onto the second grid, we are doing 1/2 of that. So that means we're doing a vertical stretch by a factor of 1/2. Let's take that blue line that we just did on the first, have the exact same number of cycles, the same horizontal stretch, and just take it down and multiply every y value by 1/2. So all our x-intercepts will still be the same. I'll just throw those all down. And now all the max and min are going to be half instead of at 1. Back and forth, back and forth. Oh, just one next there. Back and forth. And let's join up those beautiful dots. Lovely. And label it. Y equals 1/2 sine of 2x. The next one, same graph, but we are going to move it right pi over 4. So take every one of those points, move it over pi over 4. First thing you want to do is see what is the scale on our graph anyways. Here's where pi is. Pi is broken up into 1, 2, 3, 4 spots. That means our scale is pi over 4. That's what every tick mark is worth. So we're moving it over 1 tick mark. So take every point, move them over 1 tick mark. Oops, that one not there. And let's connect those up. stops there. And I need to add in this extra part that's going to come out from off screen. And finally, take the same graph and let's go down 3. So we're taking the red graph, take every point down 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Notice what we've got here. I can just continue that pattern. I don't have to count every one of them. I just know it's going to keep going like this in this order. Connect up our dots. Label your graphs so you know which one's which. 1/2 sine of 2 bracket x minus pi over, x minus pi over 4 minus 3. I didn't label the red one, so I better do that. That was y equals 1/2 sine 2 bracket x minus pi over 4. Notice that it's always double bracketed here. As soon as we bring in the translation, that's really where the double brackets is lying. Now the most important part of this is looking at the characteristics of these. So the first one, sine of 2x, the period is pi. It originally was 2 pi, but now it's pi, half of what it was originally. Amplitude is still 1. Your domain is always the domain of these ones, unless it's an application. XER, the range. It's from the max to min, -1 to 1. Phase shift, we haven't moved it right or left. And the zeros are going to happen at all those places. Then after the vertical stretch of 1/2 there, anything to do with the horizontal will be the same, period the same. But now the amplitude is half. The domain stays the same. The range is half of what it was. Phase shift still nothing. And then we've got our zeros, which will be the same because those are dealing with the x. After the horizontal translation, okay, period's still the same. Amplitude's the same as the last one there. Domain's still the same. Range still. But now we have a phase shift. We have a phase shift that is pi over 4. And it's going to the right. So we should write in there pi over 4 to the right. Give a direction. And the zeros, those now have all been shifted as well, pi over 4 to the right. And now after the vertical translation, still the same period, still the same amplitude, still the same domain. Range, though, is going to go up by 3. So we add 3 to both sides of that range. Your phase shift is still pi over 4 to the right. And there is no zeros because this now doesn't even touch the axes. And then as you can see in your book there, we've got transformations. We're looking at A, B, C, and D. And they fall exactly along with what we've done in the past. Again, I just don't like to use the word compression. We'll just talk about stretch. And now applying those transformations to sine, we've got the same form. The f from the other page is just the sine. That is the function. It's a sine graph. So we treat it exactly the same. Our a value is -1/3. What that means is that we've got two things happening. The negative is the reflection, like that. The reflection is the negative part, and your stretch, the vertical stretch, is by a factor of the 1/3. Then we move to the 1/2. That's the b value. And that's meaning we've got a horizontal stretch by a factor of 2. Then we've got a c value. The c value is negative pi, because there was a negative in the equation to begin with. And that's meaning we're translating pi units left. Or as I've said, it's a phase shift of pi units left. Or probably pi radians left. Then our d value. The d value is a -1. And that's our vertical translation, 1 unit down, or as we now use, vertical displacement of 1 unit down. And there's your bit.ly link. What transformation would be applied to this to get to there? So identify your transformations. So let's look at the process of graphing this. If you had to graph this, we're going to go through the step-by-step play. Work left to right. And apply each one of those parameters, A, B, C, and D, in that order. I'll let the lady talk to you about it. And here she is, waiting for you.
The transformations required to create the graph of y equals -1/3 sine 1/2 times x plus pi minus 1 from the graph of y equals sine x can be determined by examining each constant in the defining equation. Compare this equation to the general function. Y equals a sine b times x minus c plus d. A is -1/3. This means that there is a vertical compression by a factor of 1/3 and a reflection in the x-axis. The amplitude is 1/3. B is 1/2. This means that there is a horizontal stretch by a factor of 2. This doubles the spacing between the zeros, and so doubles the period. The period is 2 times 2 pi, or 4 pi. C is -pi. This means that there is a horizontal translation of pi units left. D is -1. This means that there is a vertical translation of 1 unit down.
Here's the summary of all of the characteristics of that graph. Amplitude, 1/3. Not -1/3. Amplitude's always positive. Period, 4 pi. We got that from the original 2 pi being divided by the b value, 1/2. Gives us our 4 pi. Pi units to the left, zeros none, domain, XCR, and our range. We got that from the graph. I'll be showing you a way of picking that off as well. Okay, so first part, predicting how the graph is related. That's really talking about your transformation language. And just read left to right all the way across to do all of them. So the first one, we've got A. We've got then a vertical translation, or sorry, vertical stretch by a factor of 1/4. The next one, so that's our yellow. The next one, our blue. That's a horizontal stretch by a factor of the reciprocal, 1/3. And we come to the green. So this is now a horizontal phase shift or a horizontal translation. It's called a phase shift. Pi over 6 units or radians to the, because it's a positive, it should have a negative in there. So that means we actually went minus a negative c value. It's going to the left. And then our final one is the pink, there, +2. And that's going to be a vertical displacement, or vertical translation, 2 units, and that's going up. part A done. Let's look at part B. We're going to sketch this. The way to sketch it is to take each one, just like you saw in that last video part, going each step by step, starting with the A, then the B, then the C, then the D, and translate it to graphic. I'm going to use the applet here to help me graph. What I've got graphed here in the blue is our cosine. And in the red, I'm going to do the transformation. So first one that we want to do is the A value. We got to change that into 0.25. You have access to this applet in your Math Excel. So if you want to use these to help you to graph them and visualize what's going on, please go to your Math Excel site. Check it out. Okay, so now we've got, look at that. The A value brought the amplitude down to half the amount, or sorry, quarter of the amount. Then we'll do our B value. Do that one next. That was a 3. Think about what it should do. Ah, there we go. Look at that. It made the period much smaller. C value. With the C value, we've got, notice that they are putting in here pi over 12. So we have to figure out what value to put in for this 0 part here to make it pi over 6. And so I'm going to need to put a 2 in there to actually make, as you can see up here, pi over 6. And oh, look at that. You can see, I'll just move this along. You can see that as I slide that, it's sliding it back and forth. Let's leave it at 2. The D value. This one, we're going up by 2. So let's check it out. And yeah, it moved it up. There you can see it. Let's look at the amplitude, which was 0.25, 1/4. The period, 2 pi divided by the B value. So our characteristics, let's go through those. I'll first start with the parameters. A is equal to 1/4. B is equal to 3. C is equal to negative pi over 6. And D is equal to positive 2. From there, we can start writing our characteristics. The amplitude is the 1/4. That's what goes to the A. The B value allows us to find our period. Period is equal to 2 pi over the B. The original period, which is 2 pi, divided by the B, or multiplied by the stretch factor of 1/3, which gives us 2 pi over 3. The C value gives us our phase shift. We got a horizontal phase shift, I'll put an HPS, horizontal phase shift of pi over 6 units left. And we've got now our D value, which is going to lead straight into our VD, our vertical displacement, of 2 units up. The other characteristics we want to talk about are our domain, that's XCR, our range from the max to the min, 1.75 less than or equal to y, less than or equal to 2.25. How do we get those parts? Okay. Let's look at that, what that would be as a fraction. So as a fraction, that's 7/4 and 9/4. Notice this, that they're both over 4. That's related to the A value being over 4, 1/4. So what we're doing for our range is we can think of it this way. Go to your midline. Okay, so there, bring it in there. Go to the midline, which is right here. And that midline which originally was at 0, is that vertical displacement up. So our D value is the midline. Go and find your midline, the D value from the equation. And from there, we're going to go up the amplitude and down the amplitude. The amplitude is the A value. So looking at your equation, our range is always going to be your D minus your A value and your D plus your A value. And that holds true here. 2 minus 1/4 and 2 plus 1/4. Now just watch out if this was a negative sign in front of the A. We're just dealing with the absolute value. Because if you do that, then your minimum would actually be your maximum would be your minimum. Don't take the negative with the A value. Just use the amplitude. And there's also no zeros on this one. So that would be the other thing that you'd want to look at. All right. Everyone's favorite. Write an equation from the graph. Here we go. With trigonometry, we can use our transformations. So they say, oh, we're going to use sine. It could be sine or it could be cosine. They both could look the same. There are many options. There's actually 4 good options that you could use to find this as an equation for this that would look the same. If we talk about any translation or any phase shift, there's really an infinite number of options, but we're always going to look at the smallest smallest possible phase shift. So let's start. Y equals A sine of B bracket, got to be double bracketed here, so you could put a bracket there if you want, X minus C bracket plus D. Let's start figuring out what each of those parameters are. Start with A and D. Those are the first 2 you always want to find. Amplitude. Your amplitude is your A value. And we find that by doing your distance from the max to the min, max minus the min, and we want half of that distance. So find your max value, 6, subtract your min value, minus -4, divided by 2, which gives us 10 over 2. Our A value is 5. Do the D value next. Your D value is your midline. If you can find the midline on there, just go straight off and find it. Or the midline is the middle, the average. To find an average, you add the 2 values and divide by how many? 2. Max plus the min divided by 2. Or in the average value. So we've got 6 plus a -4 over 2, which gives us 2 divided by 2, which is 1. When you get your midline, your D value, draw it in. Draw it in on that graph. There's a reason for that. Now, let's go to our B value now. In order to find our B value is from your 2 pi divided by the period. Or 360 divided by period in your degrees. So 2 pi divided by the period. Well, we've got to figure out what the period is. The period is, again, from max to max, min to min, someplace to where it repeats. I'm going to use the minimum to the minimum value. But before I can do that, I need to kind of know, well, what are each of these tick marks worth? Well, here's pi over 6. tick mark is half of that. So this scale is pi over 12. Always identify your scale. Or in other words, see if you can find where pi is, and pi is actually right here, right at the end, and count how many tick marks it takes to get to there. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. That means it's pi over 12 for the scale. Now we just count our tick marks. 1, 2, 3, 4, 5, 6, 7, 8. My period is equal to 8 of the pi over 12 tick marks. Take that to the lowest terms fraction. We'll divide each of them by 4. We get 2 pi over 3. So our b value is 2 pi divided by that period of 2 pi over 3. Dividing is the same as multiplying by reciprocal. 2 pi times 3 over 2 pi. The 2 pi's cancel off, and we get left with a b value of 3. C value is the hardest one to find. This is our phase shift. And we're talking about sine. So sine should have, if we did everything except the c value, the sine value should have been going up through the midline. This is the key here. That's why I drew the midline at the y-axis. So sine should go up through midline at y-axis. Up, midline, y-axis. Should have been here, going up. But it's not. We're going to find, ask yourself this question. Where is closest up through midline? Well, the closest going up through the midline is right here. Let's count how many tick marks it takes us to get there. 1, 2, 3. I went 3 to the right. 3 pi over 12s to the right. So my horizontal phase shift is 3 of the pi over 12 tick marks. Be careful not just to write that C is 3. It's not true. It's 3 pi over 12s over. Take that to the lowest terms fraction. Divide them each by 3. We've got pi over 4 to the right. That gives us our C value of pi over 4. So there's our A value, our D value, our B value, our C value. Plug it into our form to get y equals A sine B, which is our 3, bracket, x minus pi over 4, brackets, plus 1. Done deal. There's the equation of that graph. I really want you to try to get cosine of that example 2 we just did, the one we just finished doing. See if you can get a cosine graph. We'll talk about that in class, and I'll give you some tricks on how to help with getting the cosine as well. All right, good luck with those, and finish off that and your to discuss questions.